It's commercial time. Commercial. Hi. Let's talk about commercial. You guys like pizza? Oh man, I love pizza. I love pizza and sushi. I can eat them all day long. If you like me, like to eat pizza but don't want to make it, Domino's Pizza. Think about them. That's your best option. So, by the way, so I picked Domino's to do today because I used to be a driver for Domino's. And not sure, did you know that Domino's Pizza has been making pizza since 1960s? So they have a long experience of dough tossing, baking, and fast delivery. You can get your pizza hot and fresh within 20 minutes after you order. Well, if I were to be your driver, you get in 15 minutes. So it can't be any faster than that. And for COVID reason, if you request a car-side delivery anytime from 4 p.m. to 9 p.m., you get a 49% off any type of pizza. You see what they did there? So 4 p.m. to 9 p.m., you get 49% off your pizza. Don't do that. This deal does not apply anymore. That's the COVID time. So, and it's just a joke. Okay. Just make it sound like a podcast. Anyway. Chapter 3, how you guys doing so far? Hey, we're on chapter 3. So chapter 3, we just talk about atom. Ta-da. That's it. So super simple there. All right. Let's talk about atom. So start right here. Everything around us arises from matter, and we talk about matter in chapter 1, right? And all matter is composed of a basic set of elements. And if you look at the periodic table, if you look on your phone, you're going to see there are at least 118 known elements. But if you count the synthetic one, there's probably 130 something already. The list keeps going. But only 98 of those are naturally occurring, which means they exist in nature, and we don't have to synthesize it. We don't have to make it. And each element composed of different type of atoms. Okay. And have you thought about the first person who came up with the idea that everything around us made of small particles? Who ever thought it? Who had a time to think about that? Well, this person had quite some time. So this is way long back there before Snapchat was invented. So Democritus, that's in the Greek Roman era. The first person who talked about matter and atom, right? He said all this matter is made of small particles, and he called this particle a tomos. It means no, no. Tomos means cut, so uncuttable. So he said that this atom is small, it's invincible, you can't see it, and they are indestructible. You can't destroy it. Okay. And he tried to explain the fact that all this matter have different properties. So we have a liquid one, solid, or oil. And the reason this is how he gave the reason. The matter that exists in liquid form, the atom look like they are rounded and large, so they can slide off each other, look like that. Okay. The solid one, the atom structure, the size, they are pointy. The shape, so they stick in place. And for the oil, they are small and fine. Okay, so Democritus was the first person who came up with the atom idea. Okay, and that's at the same time we have Aristotle. I'm sure this guy is pretty famous. Who said that no, those are wrong. All matters is made of 4 elements. Have you watched that show? No, well, totally wrong, but it persisted for 2,000 years because I think Aristotle was the leader of the Greek or Roman, whatever, at that time. And the winner write the history, right? And he kept telling other people, and people believe in it. And this idea lasted for a while. So in the new era, we have John Dalton, an English chemist, who came up with the atomic theory. Okay, the first person is a new era now. And he said that all element is made of this extremely small particles called atoms. And all elements, they have different property because atoms have different size, different mass, different property. Okay. And he suggests that atom is small, cannot be made it smaller than that, can be created, can be destroyed. That's kind of true. We can create atom, we can destroy atom. Atom is just like energy, can be created, can be destroyed. But we can make it smaller. Yeah, but we don't know that until 19th century, when we realize that, oh, inside an atom we have a neutron, proton, and electron, right? So at this time it's true. And John Dalton also said atoms are from different elements combined with a simple whole number. And we mentioned this before. To make water, we need 1 oxygen to 2 oxygen, 1 to 2 ratio, right? To make the methane, CH4, and oxygen, so the ratio is 1 to 4 ratio. You make carbon dioxide and 2 molecules of water. Okay, so there's a whole number ratio right here. We'll talk about this later. And he also suggests that in chemical reaction, atoms are combined, separated, and rearranged. And which is true. Take a look right here. So atom rearrange, so separated, and then combined to get water. All of them, they had this happen. Combined, separated, and rearranged. And he came up with not the periodic table yet. It's more like a list of elements. And let's take a look at the list real quick. So we have hydrogen. That's what we have in the current periodic table. I don't know what that is. We have carbon. We have oxygen, phosphorus, yes, sulfur, magnesium. This is probably magnesium. Lime, I don't know what this really is, but I'm guessing this is limestone, maybe calcium carbonate. Soda, I'm guessing that's sodium hydroxide, which is a compound, not an element. Potash, that's probably potassium, I think, maybe. Strontium, we have it. I don't know what that is. Iron, zinc, copper, lead, silver, gold, platinum, mercury. We have that in the modern periodic table. Okay, and at the same time, so this is a new era now. So this guy, don't call him Anthony. No, he's a French chemist. His name is Antoine Lavoisier, not Anthony. So Antoine Lavoisier came up with the law of conservation of mass. He's saying that in a chemical reaction, matter is neither created or destroyed. Similar to the law of conservation of energy, right? Energy cannot be created or destroyed, but it can transform. Right? Same thing with atom right here. Same idea. So from his experiment, based on his research, he formulated this law. And he said that, well, if you want to make water from hydrogen and oxygen, and you add 4 grams of hydrogen, 32 grams of oxygen, so the total 36 grams in the reaction flask, whatever it came out, which is water, if it's not leaking or anything, it's going to stay at 36 grams. You can't create, you can't destroy the mass or matter. Okay? All right, let's try this with me real quick. So if 16 grams of methane react with 64 grams of oxygen, okay, so methane and oxygen, and 36 grams of water are produced, how many grams of carbon dioxide are produced in this reaction? Pause the video, think about that. All right, let's check it. So we have 16 grams of methane, 64 grams of oxygen, and we get what? 36 grams of water. How many grams of carbon dioxide do we get? Well, the law of conservation of mass. So on the left, math on the left, before you adding and after coming out, they have to be the same. Do the math. It's easy math. So 44. Okay. All right. We have a concept test right here. So which of the following chemical reaction does not follow the law of conservation of mass? Which one doesn't make sense? Well, let's see. 4 blue. 1, 2, 3, 4, 5, 6, 7, 8. 8. Was it? This probably hydrogen. Oh, this is hydrogen. This is nitrogen and hydrogen, right? The blue actually the nitrogen. The white, those are hydrogen. So we have 4 nitrogen, 8 hydrogen. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Yep, still the same. 2 nitrogen. 2 nitrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, still the same. Last one for sure. This one. 4 nitrogen atoms. 3 nitrogen atoms. Doesn't make any sense. Okay. All right, next video, we're going to talk about how we came up with the periodic table. It's fun to talk about it.